Hello and welcome everyone. I am Navjot, your guide for today's enlightening journey. I am a fervent science enthusiast with a special fondness for making intricate topics simple and engaging. My passion lies in peeling back the layers of complex scientific concepts and presenting them in a way that makes learning a delightful experience. Today, we're going to embark on a riveting exploration of a topic that's as captivating as it is crucial to our existence. We'll be delving into the heat balance of the Earth from the Sun. This fascinating mechanism is the reason why we experience different climates and weather patterns around the globe. It's a topic that touches upon the very essence of our planet's survival and our own existence. So prepare for a journey that's as enlightening as it is exciting. We're going to unravel the mysteries of the Sun and Earth's intricate relationship. Buckle up and prepare to delve into the fascinating world of Earth's heat balance. Now imagine the Sun as a massive fiery ball showering Earth with heat and light. A sight to behold, isn't it? But have you ever wondered how this celestial body, located approximately 93 million miles away, manages to heat up our planet? Well, let's dive into that. The Sun, the star at the center of our solar system, is the primary source of Earth's heat. It's a giant nuclear reactor where intense heat and pressure cause hydrogen atoms to combine to form helium, a process known as nuclear fusion. This process releases a tremendous amount of energy in the form of light and heat, which is projected out into space in all directions. This energy travels through space in the form of electromagnetic waves, specifically in what we refer to as solar radiation. Think of these waves as tiny packets of energy, or photons, racing towards Earth at the speed of light. Quite literally, light speed travel. But what happens when these energy packets reach Earth? Well, they interact with our planet's atmosphere and surface. Some of this energy is reflected back into space, but a substantial portion is absorbed by the Earth, heating it up and making life as we know it possible. The Sun's heat doesn't reach every corner of the Earth equally though. Factors like the tilt of the Earth's axis and its elliptical orbit around the Sun create variations in the distribution of sunlight. This is why we experience different seasons and why temperatures differ from the equator to the poles. It's remarkable, isn't it? The Sun so distant from us, yet so influential in our daily lives. Without the Sun's heat, our Earth would be a frigid, lifeless ball of rock. It's the Sun's energy that drives weather patterns, powers photosynthesis in plants, and has a fundamental role in regulating Earth's climate. So, the Sun showers Earth with its warmth, but how does our planet manage this heat? Let's find out. Imagine a protective blanket around Earth, our atmosphere, playing a crucial role in maintaining heat balance. This is not just a figment of imagination, but a reality that we live in. Our atmosphere is a complex system that performs a delicate dance with the Sun's heat. It absorbs some of the incoming heat, preventing our planet from freezing. It reflects and scatters a portion of it back into space, stopping us from overheating. But that's not all. The atmosphere also helps distribute this heat around the world, ensuring that the temperature differences between day and night or between equator and poles are not extreme. It's like a global thermostat, fine-tuning the Earth's temperature to create a just right condition for life. Our atmosphere is indeed Earth's thermal regulator, but there's more to this heat balance story. Earth's surface, a mix of land and water, is the stage where the Sun's heat performs its act. This surface absorbs a hefty portion of the incoming heat, but not all surfaces are created equal in this absorbing game. You see, different surfaces have different heat absorption capacities. Imagine a hot summer day at the beach. The sand burns underfoot, absorbing the Sun's heat rapidly, while the water remains relatively cool. That's because water absorbs heat slower than the land, and it's much the same with ice, which reflects more heat than it absorbs. But what about forests? With their dense foliage, forests absorb a lot of the Sun's heat, but they also create shade, which helps to lower temperatures underneath the canopy. While Earth's surface basks in the Sun's warmth, it also has a mechanism to release this heat. But we'll get to that in the next scene. For now, let's marvel at the fascinating interplay of heat absorption on our diverse planet. Like a thermal dance, Earth not only absorbs the Sun's heat, but also gives it back to the space. Now let's delve into how this process of heat release happens. Imagine our planet as a giant spinning ball in space being warmed by the Sun's rays. As it absorbs this heat, it also needs to cool down to maintain a balance. This is where the magic of radiation comes in. Radiation is simply the process by which heat is transferred in the form of waves or particles. It's like how the warmth from a campfire can be felt even when you're not directly touching it. In this grand cosmic dance, Earth acts like a radiant dancer, absorbing heat from its fiery partner, the sun, and releasing it back into the cold, dark space. This brings us to a cool scientific concept known as black body radiation. Now, don't let the fancy term intimidate you. A black body is an idealized object that absorbs all incoming light and doesn't reflect or transmit any of it. In other words, it's the perfect absorber and emitter of heat. Our Earth behaves somewhat like a black body. It absorbs the sun's heat during the day and releases it back into space at night. This constant exchange of heat keeps our planet from overheating or becoming too cold, maintaining a temperature that's just right for life as we know it. But here's the thing, the Earth doesn't release all the heat it absorbs. Some of it is trapped by our atmosphere, creating a natural greenhouse effect that keeps our planet warm enough to support life. It's a delicate balance, a finely tuned dance between the Earth and the sun, the atmosphere and space. Now that we've understood how Earth releases heat, what happens when this balance is disrupted? That's what we'll explore next. But for now, let's marvel at the elegance of this thermal dance, an intricate ballet that has been going on for billions of years, making Earth a perfect stage for life to flourish. A perfect balance of heat absorption and release maintains Earth's comfortable temperature. But what if this balance is upset? Now that's a question that can lead us down a rabbit hole of intriguing yet alarming possibilities. So, let's dive in. Imagine a teeter-totter perfectly balanced with equal weight on both sides. That's Earth's heat balance. But when this balance is disrupted, we swing either towards excessive heat, resulting in global warming, or towards chilling cold, leading to ice ages. How does this happen? Well, it all comes down to greenhouse gases. These are gases in Earth's atmosphere that trap heat. They let sunlight in but keep some of the Earth's heat from escaping back into space. In small amounts, greenhouse gases are beneficial. They keep our planet warm enough for us to live. But too much of them, and we're in for a hot mess, quite literally. The key troublemaker among these gases is carbon dioxide. It's released when we burn fossil fuels like coal, oil, and gas. The more we burn, the more carbon dioxide we pump into the atmosphere, and the more heat gets trapped on Earth. This causes temperatures to rise, resulting in global warming. And we're already seeing its impacts: melting polar ice caps, rising sea levels, and more frequent and severe weather events like hurricanes and droughts. On the flip side, if for some reason the amount of greenhouse gases were to decrease drastically, less heat would be trapped. This could plunge us into an ice age, with all the frosty troubles that come with it. So, you see, the heat balance of our planet is a delicate thing. A minor disruption can have major consequences. It's a bit like walking a tightrope, where a small misstep can lead to a big fall. The delicate balance of Earth's heat is crucial for life as we know it. Let's wrap up our journey with a quick summary. Our journey through Earth's heat balance has been enlightening, hasn't it? We've journeyed from the fiery heart of our solar system, the sun, our primary source of heat, to the intricate workings of our own planet. We've explored how Earth's atmosphere plays a crucial role in maintaining this balance, acting like a protective blanket, absorbing and redistributing the sun's heat. Then, we delved into Earth's surface, understanding how it absorbs and reflects this heat, a process vital to our survival. Our exploration didn't stop there. We ventured into the fascinating world of Earth's heat release mechanism, a complex system that ensures our planet doesn't overheat. And finally, we discussed the potential consequences of disrupting this delicate balance, a topic that's more relevant today than ever before. And with that, we come to the end of our journey. I'm Navjot, signing off. Remember, keep exploring, keep learning,